My dear students, I welcome you all in today's topic, preparation of benzopinacol from benzophenone. When benzophenone undergoes the reaction with isopropyl alcohol in presence of catalytic amount of acetic acid and sunlight, then photoreduction happens and we get benzopinacol and acetone. Benzopinacol is the dimer of benzophenone and isopropyl alcohol undergoes oxidation to acetone. We can call this reaction as an example of green synthesis. Now coming to the brief procedure of this, how to do this reaction. 1 gram of benzophenone, if we dissolve it in 15 ml isopropyl alcohol in a dry test tube, if it is required then we can warm little on hot water bath. After that 1 drop of glacial acetic acid can be added. After addition of this 1 drop of acetic acid, the test tube can be covered with cotton or paper and can be kept for the bright sunlight for 7 days. During these 7 days, we can be able to see the crystals of benzopinacol is growing, and if we check the TLC, depending on the progress of the reaction, we can filter that solid benzopinacol, and this benzopinacol is pure enough so that recrystallization is not required. After drying this product, we can take the yield and melting point also can be checked. Now coming to the calculation of the percentage yield, means if we want to calculate the percentage yield, then we have to follow one formula, that is the percentage yield is equal to weight obtained of the product divided by theoretical yield of the product multiplied by 100. Now let us calculate the theoretical yield of benzopinacol from 1 gram of benzophenone. Now from the balanced equation, if we see the 2 gram molecular weight of the substrate means the benzophenone, we get the 1 gram molecular weight of the product. Now what is the gram molecular weight of benzophenone and what is the gram molecular weight of benzopinacol? If you look at the molecular formula of benzophenone and the benzopinacol, it is clear that benzophenone molecular weight is 182 and molecular weight of benzopinacol is 366. So therefore 2 into 182 grams of benzophenone can gives rise to the 366 grams of benzopinacol. So therefore 1 gram of benzophenone gives how much benzopinacol? If we calculate, it comes 1.005 gram. Now after preparing this compound, if we take the weight, then say that is x gram. So what will be the percentage yield is equal to x gram divided by 1.005 gram into 100. Whatever value will come, that will be considered as the percentage yield. Now in this regard, it is better if we discuss how to calculate the moles of the organic compounds. So let us practice with the benzophenone. Now in order to calculate the moles, we will be having one formula, that is the number of moles is equal to weight in gram divided by gram molecular weight. Means 1 gram of the benzophenone if we take, then in terms of moles 1 gram of benzophenone means how many moles? As simple as this. So in order to calculate the number of moles, it is 1 gram divided by 182 grams. So it is 0.00549 moles. If we try to convert it into the millimoles, then we have to multiply this by 1000. So therefore, what is 0.00549 moles means is equal to 5.49 millimoles. Now coming to the mechanism of this photoreduction where the benzophenone can be converted into the benzopinacol in presence of sunlight. Now the molecule benzophenone is present in the singlet ground state S0. Now when the light falls, then it gets excited to the first excited state singlet. Now at this particular stage S1, it undergoes the intersystem crossing and the S1 gets converted into the T1. Now benzophenone in T1 state undergoes the interaction with isopropyl alcohol, and isopropyl alcohol undergoes the dissociation of carbon hydrogen bond. Homolytic cleavage happens, and after this homolytic cleavage H dot is abstracted by the O dot. So next again the benzophenone which is present in the T1, it undergoes the similar procedure, means it abstracts the H dot, but this H dot is obtained not from the homolytic cleavage of carbon hydrogen bond, it is obtained from the homolytic cleavage of the oxygen hydrogen bond, and isopropyl alcohol after this decomposition gets converted into the acetone. Now these two molecules of free radical undergoes the dimerization to give benzopinacol. So now we are coming to the next important question, that when we have to stop this reaction and how do we know that reaction is finished. Now the progress of the reaction can be monitored by checking thin layer chromatography. So time to time, if possible every day after putting the reaction in the test tube, first day, second day, third day, like that every day we have to check the TLC. Now in order to check the TLC, we have to take the crystal which is there in the test tube, I mean the newly formed crystals, and then we have to dissolve it in the acetone. In another container, we have to prepare the, we have to take the benzophenone and we have to dissolve it in the acetone. So we will be having the two solutions in acetone. One is the product which is formed in the test tube, another one is the substrate benzophenone. Now after taking a pre-coated TLC plate, we have to give the 3 spots. In one side the product, in another side the substrate benzophenone, and at the middle we have to give the spot for the both, means the substrate benzophenone as well as the product obtained from the test tube. So this is called as a co-TLC, which we are putting at the center. Now this TLC plate will be run by using the eluent. That eluent usually can be established by trial and error method, and we use the PET ether chloroform mixture. Now after running this TLC plate by using this eluent, we have to take it out from the TLC chamber and we have to detect the position of the spots of benzophenone and benzopinacol by putting this TLC plate in UV chamber. Now if in the crude product spot still starting compound benzophenone spot is there, it means that reaction is incomplete and we have to keep our test tube for some more days in the sunlight unless and until the substrate spot, I mean the benzophenone spot, vanishes. So in this element benzophenone is the less polar, it is moving faster, and our product is moving slower, means it is more polar than our substrate. Benzopinacol is more polar than substrate benzophenone by using this eluent PET ether and the chloroform. Now after getting this thing, after 3 or 4 days, or if the sunlight is bright, it may take the less time, whatever it is, in the TLC, when the product spot is pure and the product spot does not contain any benzophenone spot, in that case only we have to consider reaction is over, and then we have to collect the product by filtering the solvent. Now from this TLC plate, another important thing we have to do, that is the calculation of the retention factor of benzophenone and benzopinacol. We have one formula, retention factor RF is equal to distance travelled by compound divided by distance travelled by eluent or solvent. So in this picture, when we are calculating the RF value of benzophenone, then it is A centimeter by C centimeter, means it is A by C. When we are calculating the retention factor of the product, then it is B centimeter by C centimeter, means it is B by C. Now after calculating, as because A is greater than B, then this RF value of 1 will be greater than RF value of 2. So by comparing the RF value, we can be able to understand which one is more polar, which is less polar. Less polar compound move faster, more polar compound move slower. So the lower the RF value, higher will be the polarity of the compound. Now let us discuss the important spectral features for substrate as well as the product. What will be the difference between the substrate benzophenone and the product benzopinacol in terms of mass spectrometry, IR, NMR and C NMR. Now coming to the benzophenone, if we record the mass spectrum of the compound, it will give the molecular ion peak at M by Z 182, and it will undergo the alpha homolytic cleavage. If it undergoes the alpha homolytic cleavage, then pH dot goes, we will end up into the base peak at M by Z 105. Base peak means the most intense peak, and benzoyl cation that will appear at M by Z 105. And then from this benzoyl cation, the neutral molecule carbon monoxide will go, we will land up into the phenyl cation at M by Z 77. Now coming to the IR spectrum of this molecule, as IR is meant for the functional group, so this molecule contains the functional group C double bond O. The C double bond O is conjugated, so therefore the newer C double bond O stretching frequency will appear at the 1700 centimeter inverse, which is slightly lower than the non-conjugated C double bond O stretching frequency, as for example it is in the acetone or in the cyclohexanone, which appears at approximately 1715 centimeter inverse. Here it is little low, and that is because of effect of conjugation. Now coming to the 1H NMR of this benzophenone, this molecule has total 10 hydrogens because the molecular formula is C13H10O, and all the hydrogens give rise to the only 3 signals because this molecule is highly symmetrical. There are 2 orthohydrogens will give 1 signal, 2 metahydrogen will give 1 signal, and the parahydrogen will give another signal, and that will be repeated for the another phenyl ring also, because this molecule contains 2 phenyl ring. So now coming to what it is called the approximate delta values and their multiplicity, as because C double bond O is the electron withdrawing group, so therefore ortho position will be having the higher value, para position also will be having higher value, and the meta position will be having slightly lower value. If we consider the resonating structures, then it is very clear that positive charge will come at the ortho position and the para position. Therefore, ortho and the para position will be higher value than the meta position. Now coming to the ortho hydrogens, which appears at delta 7.8, and ortho hydrogen will undergo the coupling with the meta hydrogen, so it will appear at the doublet, and there are 4 ortho hydrogens are there. Now coming to the next peak, that is delta 7.6, that will appear, that is because of the para hydrogens. The para hydrogens have the neighbor meta hydrogens. So the multiplicity of para hydrogens will be triplet, and there are 2 para hydrogens in this molecule. Now coming to the lowest value, that is because of the meta hydrogens, that is delta 7.5. One meta hydrogen will be having the 2 neighbors, so therefore it will appear as a triplet, and there are 4 meta hydrogens. So therefore this is all about the 1H NMR of this benzophenone. Now coming to the C13 NMR of this compound, this will be having the total 5 signals in the, singlets in the BB spectrum of this benzophenone. These 5 signals are from the highest value to the lowest value. If we arrange, C double bondo has the highest value, followed by the ipso carbon, means the C1 carbon in the aromatic ring. Then as because the C double bondo is electron withdrawing, then what it is the para carbon followed by ortho carbon, and then the lowest value will go to the meta carbons. So if we see the values, C double bondo has the highest value, that is at delta 197. Then ipso carbon appears at delta 138, para carbon appears at 132, ortho appears at 130, and the meta appears at delta 128 ppm. So in this way, these are the 4 characteristic spectral features of the substrate benzophenone. Now we will slowly go to the product, and we will see lot of differences are there in the mass IR, H NMR and the C13. Now coming to the product benzopinacol, the mass spectrum of this compound, if we record, then molecular ion peak will appear at M by Z 366, and then from this, if it's a symmetrical molecule, that sigma bond, if it undergoes the cleavage, then we will be getting the 366 divided by 2 means M by Z 183. Now from this, because of the rearrangement, if the benzene molecule goes, means there will be the loss of mass 78. So we will end up into the that is benzoyl cation of M by Z 105, and from this, if carbon monoxide goes, then we will end up into the phenyl cation, which appears at M by Z 77. Now coming to the IR spectrum of this product benzopinacol, it is very clear that the substrate benzophenone contains C double bondo, but the product does not contain the C double bondo. So therefore the peak at nu bar 1700 centimeter inverse will not be there here. So disappearance of peak at nu bar 1700 centimeter inverse also indicates the completion of the reaction, what we are getting from the TLC. Here also, by recording the IR also, we can be able to know the completion of the reaction. Now this compound contains the functional group alcoholic OH, and it undergoes the intramolecular hydrogen bonding. So if we record the IR, that OH comes as a broad singlet at near about 3400 centimeter inverse. Now coming to the 1H NMR of this molecule, they are highly symmetrical molecule. So only 2 peaks comes here. All the phenyl rings gives what it is called the only one signal, that is multiplate at 7.5 to 7 ppm. Now it's with respect to phenyl ring, ortho hydrogen, meta hydrogen, para hydrogens are there, but that group is very weak. So therefore this ortho hydrogen, meta hydrogen, para hydrogen, everything comes as a together multiplate. And now coming to what it is, and total 20 hydrogens will come as a multiplate. These are all aromatic hydrogens, will give the signal between 7.5 to 7 ppm. Now the leftover is only the alcoholic OH signal, that is for 2 hydrogen, and it appears at a delta 2.9. Of course, this OH signal does not have any fixed position, because it depends on the concentration, and also it depends on the hydrogen bonding. Now coming to the C13 NMR of this compound, so here also we will be having that the 5 signals will come in the C13 NMR of benzopinacol. Now highest value, of course, it goes to the ipso carbon, and this group is electron donating group. So meta carbon will be having the higher value over ortho and the para, because if we draw the resonating structure, because this group is electron donating group, negative charge comes on the ortho and the para, so therefore they get shielded over the meta. So first is the ipsocarbon followed by meta, next is orthopara, and these are all the above 100 peaks because they are representing the phenyl ring. Now coming to the OH bearing carbon, that carbon is sp3 hybridized and will definitely will give the signal below 100, and that is approximately 80 ppm. Now these 5 singlets come if we record the broadband decoupled spectrum of C13 NMR. So these, in this way, all the 4 characteristic spectral features of benzophenone and the benzopinacol are completely different. Now let us discuss some important questions based on this laboratory preparation. The first question is that what can be one alternative method to prepare this benzopinacol. Now, as because this is one reduction, so it can be done by using the metal acid as reducing agent. So benzophenone can undergo the metal acid reduction to get the product benzopinacol.